$100 trillion.
Yeah, with a capital T.
That is a number so big it actually hurts my brain a little bit to think about.
That doesn't sound
It
right.
sounds completely imaginary, but that is the number we are starting with today. $100 trillion.
Yeah.
I mean, that's the global gross domestic product, the entire economic output of our planet.
It is a staggering figure. It really is. It represents, every coffee sold, every car built,
Yeah.
every single software license.
Every medical procedure.
Everything.
Mm.
But the reason we're starting there isn't just to be impressed by the sheer size of the global economy. It's to look at how that pie is actually sliced.
Okay.
Because I think most of us, when we sit down to talk about innovation or tech or, the future of the economy, we have a very specific image in our heads.
Oh, for sure. We immediately picture Silicon Valley. You
Exactly.
picture apps, social media, search engines, the cloud.
The world of bits and bytes. But here is the reality check that sets the stage for our entire deep dive today. And frankly, it might change how you look at the world around you.
I'm ready.
That digital world, the world of pure information, that is only about 25% of that 100 trillion.
Wow. Okay, which leaves a massive 75% chunk just sitting right there on the table.
$75 trillion. And that comes from the physical world.
The real world.
The real world. Manufacturing, healthcare, logistics, energy, construction, transportation, agriculture. Real things. Heavy assets. Steel, concrete, moving parts. The stuff that actually keeps us alive and moving.
Steel meets silicon.
Precisely. And that brings us to the book we are exploring today. Fusion Strategy. How Real-Time Data and AI Will Power the Industrial Future. It's by Vijay Govindarajan and Venkataraman.
Right.
And frankly, this is a wake-up call. Because for the last 20 years, the narrative has been very, very one-sided. The digital giants, the asset-light companies, have been eating the world.
They sure have. They've disrupted everything from how we buy books to how we hail a cab.
And the industrial giants, the companies making the tractors and the jet engines and the MRI machines, they've looked a bit like dinosaurs in comparison.
Big, slow, analog dinosaurs waiting for the meteor.
But the authors argue that the meteor missed, or maybe a better way to put it is, the dinosaurs are evolving. We are standing at the precipice of what they call the fusion frontier.
The fusion frontier, I like that.
And this isn't just about, putting a chip in a tractor and calling it a day. That's the old Internet of Things hype.
Right, that's been around for a decade.
This is about a fundamental collision between the physical and the digital. And the mission for this deep dive is to understand how that $75 trillion physical economy is about to fight back.
I love this concept. Because you're right, we used to think of tech as just the phone in our pocket. But now, a tractor is tech. A jet engine is tech.
An entire skyscraper is tech.
It feels like the definition of technology is expanding to swallow the physical world.
And if you're a leader in an industrial company, or just someone observing the economy, the message is crystal clear. The past is prologue. The digital natives won the first round because they mastered data. But the next round, the bigger round, belongs to the companies that can fuse massive physical assets with real-time intelligence.
So, okay, let's map out where we're going today. This is a huge topic, so we need a flight plan to make sure we cover all the nuance here.
We do. We're going to start by understanding the new rules of competition, specifically this really critical concept called data graphs. If you don't understand data graphs, you don't understand the future of business. Full stop.
Data graphs, okay.
Then we'll look at the toolbox of fusion, something called tripartite twins.
Tripartite twins. That sounds like a sci-fi concept.
It feels like one, but it's incredibly practical. Then we're going to spend the bulk of our time in the four battlegrounds. This is the core strategy matrix of the book. Whether you're building products, selling services, integrating systems, or solving massive problems, there is a specific strategy for you. And finally, we'll talk about execution. The leadership principles needed to pull this off, and how generative AI acts as, rocket fuel for the whole thing.
Okay, let's unpack this. Part 1, the new rules. We have to talk about why the digital natives, the Amazons and Netflixes of the world, won in the first place. You mentioned data graphs. Now, I know what a database is. I think I know what a graph is. But what is a data graph and why is it different?
This is the crucial distinction. It's so important. Most traditional companies, even the big successful ones, run on what we call systems of record.
Which just sounds incredibly boring. It sounds like accounting.
It is. It's static. It's a ledger. It says, customer A bought product B on date C for price D. And that's it. It sits in a server somewhere, collecting digital dust until someone needs to run a quarterly report or audit the books.
It's dead data.
It's dead data. It's a snapshot of the past. It's a receipt.
Okay, so it's a receipt, a very expensive receipt.
A very expensive receipt. A data graph, on the other hand, is alive. It's dynamic. It captures relationships, links, and interrelationships between the product and the user in real time.
Okay, give me an example.
Think about Netflix. A system of record would just say, you rented The Matrix. End of story.
Right.
A data graph says, you started watching The Matrix at 8 p.m. on a Tuesday. You paused it at the 12-minute mark. You rewound the lobby shootout scene 3 times, and you turned it off the second the credits rolled.
And because it knows that, it knows me. It knows I like action. It knows I have a short attention span. It knows I watch movies on Tuesdays.
It knows you better than you know yourself.
Okay.
And it has 3 key elements. First, you have scale. We're talking millions and millions of users.
Nodes.
The nodes. Second, you have scope, the richness of that data. It's not just what you watch, but how you watch
The
it.
rewinding.
And third, and this is key, speed's happening right now, that is the Netflix movie graph. Or think about Uber. They have a mobility graph. They aren't just dispatching cars. They are analyzing traffic patterns, driver behaviors, rider preferences, weather impacts, all in real time across millions of points.
So their argument is that the digital natives won because they built these living nervous systems, these data graphs, while industrial companies were just building lists.
Exactly. The digital natives built a nervous system. The industrial companies build a filing cabinet. And this leads to the engine of their success, data network effects. Now, we need to be careful here because network effects is a term that gets thrown around a lot in business schools and boardrooms.
For sure. The classic example is the telephone, right? If I have the only telephone in the world, it's a paperweight. If you get one, it's useful.
A little bit useful.
And if everyone gets one, it's essential. That's a direct network effect.
Correct. That's a direct network effect. More users equals more value for everyone because the users can connect to each other. Simple. Then you have indirect network effects, like the App Store.
Right. More iPhone users means more developers build apps.
Which makes the iPhone better, which brings in even more users. The two sides of the market feed each other.
Okay. But data network effects are different.
They are subtle, but they are incredibly powerful. A data network effect happens when a product gets smarter, the more people use it. And this works even if the users never, ever talk to each other.
Give me an example of that.
Google search is the perfect one. If you search for something really obscure and you click the third link, Google learns. It says, aha, for this weird query, the third link was actually the good one. The very next person who searches for that same term sees that link bumped up to the top. You didn't interact with that person, you don't know them, but your data made their product better.
And that creates a virtuous cycle.
A powerful one. More users generates more data. More data creates smarter algorithms. Smarter algorithms create a better product.
A better product attracts more users, and the loop closes.
And the loop tightens. This is why it's so hard to build a Google killer now. They have a 20-year head start on this virtuous cycle. Their algorithms have learned from trillions of interactions.
So, okay, this brings us to the industrial giants. The companies making the $75 trillion worth of physical stuff. The temptation is to look at Google or Netflix and say, okay, we'll just do that. We'll build an industrial Facebook.
And that is exactly what they should not do. Or I should say, they can't just copy-paste the strategy because the industrial world is fundamentally different.
Right.
The authors do this, what they call carpet-style analysis, just laying it all out of why industrial data graphs are infinitely harder and, more importantly, have much higher stakes than consumer ones.
Harder how? Let's break that down.
Okay, first, let's talk about the stakes.
Yeah.
If Netflix's algorithm messes up and recommends a romantic comedy when you wanted an action movie, what happens?
I'm annoyed. I waste 5 minutes. I survive.
You're annoyed, you scroll past it, maybe you tweet about how bad the recommendation was. The stakes are
Low. Very low.
right. Now, imagine you're GE or Rolls-Royce making a jet engine. If your algorithm messes up and misses a tiny vibration that indicates a turbine blade is about to shear off,
That's catastrophic.
it's catastrophic. People die. The tolerance for error in the physical world is near zero. You cannot move fast and break things when you're building a bridge or a nuclear reactor or an autonomous vehicle.
That's a really heavy point. In software, a bug is an inconvenience. In hardware, a bug can be a disaster.
Exactly. And then there's the complexity of the data itself. Consumer data is mostly just clicks. It's binary. You know, did you click or not? Did you buy or not? Industrial data is what they call multimodal.
Multimodal, meaning many modes.
Exactly.
Hmm.
Think about all the data streaming off a modern wind turbine. It's not just one thing. It's the sound of a bearing grinding. That's audio data.
Okay.
It's the heat signature of a battery. That's thermal data. It's the vibration of a chassis. That's physics data. It's video feeds of the blade spinning. It involves physics, chemistry, engineering. You have to fuse all those different talks of data into one single coherent picture.
Steel meets silicon indeed. That sounds incredibly difficult. So if the data is harder and the stakes are higher, what is the tool set? You mentioned tripartite twins. I'm guessing this is the industrial answer to the data graph.
It is. It's the engine that builds the industrial data graph. And you've probably heard the term digital twin.
Sure, yeah. It's a virtual replica of a physical object. Like architects use them to model buildings, engineers use them to design cars before they build them.
Right, but usually companies treat that as one thing.
Mm.
Here is the digital file. The authors argue you actually need 3 distinct twins that are linked together to create a true industrial data graph.
3 twins. Okay, let's break them down. Twin number 1.
Twin number 1 is the product twin. This is the as-designed twin. It lives in R&D. It's the CAD file, the physics simulation. It's the perfect platonic ideal of the machine,
The blueprint.
the blueprint on steroids. It represents what the engineers intended to build.
Okay, the dream of the machine. What's number 2?
Twin number 2 is the process twin. This is the as-manufactured twin, because, as you know, no two things are ever built exactly perfectly.
Mm-hmm.
This twin captures the factory floor data. Which specific robot welded this joint? What was the humidity in the factory on that particular Tuesday?
Hmm.
What batch of steel did this specific bolt come from?
So now we know what it was supposed to be and exactly how it was actually built.
But here's the missing link. The third one, the one that changes everything. The performance twin. This is as deployed. This is the real-time data streaming back from the product while it's out in the wild doing its job.
And this is where most legacy companies fail, right?
100%. They have the design data locked away in engineering. They have the factory data locked away in operations. But once they sell the car or the tractor or the toaster, it disappears into a black hole.
Yeah.
They only hear about it if it breaks and comes back for warranty service.
Yeah.
And the authors call this data debt. If those 3 twins, product, process, performance, are siloed and don't talk to each other, you have massive data debt.
The authors use Tesla as the golden example here to illustrate what happens when you connect all 3. And the example they use is, it's grim, but it's really effective. The crash investigation.
It's a powerful example because it shows the speed of the loop. Imagine a traditional car maker. A car crashes on a highway.
Okay.
The manufacturer might not even know about it for weeks.
Oh.
They have to send out a team. They have to physically inspect the wreck. They might have to download data from a black box if it even survived. It takes weeks, maybe months to figure out what happened.
And Tesla.
Because they have the tripartite twin linked up.
Yeah.
The moment that crash happens, or even milliseconds before, the car is streaming data. Tesla headquarters knows immediately. Instantly.
Yeah.
They can pull up the performance twin. What was the speed? Was autopilot engaged? What did the cameras see? What was the steering angle?
And they can instantly match that against the product twin, the design limits of the car and the process twin.
Yes. Was there a defect in how this specific car was built? Which robot installed that component? They can run a simulation of the crash using the real-world data against their design models. And if they find a flaw in the software,
They can patch it.
they can patch it and push an over-the-air update to every other car on the road overnight. That is fusion. That is using real-time data to fundamentally change the value of the physical asset.
It's incredible. It turns a tragic event into a learning moment for the entire fleet. The whole organism of Tesla cars gets smarter because of that one single event.
That is the data network effect in the physical world.
Yeah.
And notice, the other Tesla drivers didn't talk to each other. They don't know each other. But their cars got safer because one car provided its data.
Okay, so we have the rules, which are data graphs. We have the tools, the tripartite twins. Now we get to the fun part, the strategy. The authors lay out a matrix because it's a business book. There has to be a 2x2 matrix.
The law.
It's the law. And this defines the 4 battlegrounds where industrial companies can compete.
Right. And for our listeners visualizing this, just imagine a simple chart. The horizontal axis is the reach of the data graph. On the far left, it's just about machine efficiency, making your one machine run a little better.
Okay.
On the far right, it's about custom outcomes, making your customer's entire business run better. So it goes from your product to their business.
And the vertical axis.
The vertical axis is the richness of the data. At the bottom, it's just data from a single product. At the very top, it's data from multiple interlinked products, so systems of things working together.
Okay, so bottom left, top right. 4 quadrants, 4 battlegrounds. Let's hit battleground number 1, fusion products.
This is the battle of brilliant machines. This is where most industrial companies start. You take your standalone product, your tractor, your car, your MRI machine, and you infuse it with sensors and AI to make it intelligent.
So the key shift here is from thinking about units sold to data collected.
Exactly. And the star of this show, besides Tesla, is John Deere. Now, I love this example because people think of Deere as, old economy.
Big green tractors.
They make tractors, they deal with mud, but they're running one of the most sophisticated AI operations on the planet.
We have to talk about See & Spray. This feels like the perfect example of fusion in action.
It is. So let's look at the old way of doing things. If you're a farmer and you have weeds in your soybean field, what do?
You hook up a massive sprayer boom to your tractor, and you just douse the whole field in herbicide.
It's the carpet bombing approach.
Yeah.
And it kills the weeds, sure.
Yeah.
But it's incredibly expensive. Herbicide costs a ton of money. It's bad for the environment. And it dumps chemicals on your actual crops, too, which can stress them.
Yeah.
It's wildly inefficient.
So what did Deere do?
They developed See & Spray. So imagine this huge boom arm attached to the tractor, and it's lined with high-resolution cameras and some really powerful processors. As it moves through the field at 15 miles per hour, which is fast for a tractor.
That's flying. It's flying. And it's taking pictures of the ground constantly.
And we're talking high-speed data processing here.
We're talking milliseconds. The onboard AI analyzes the image, identifies that's a soybean plant, that's a weed, and if, and only if, it sees a weed, it triggers a specific nozzle to spray just that weed.
It's a sniper rifle instead of a carpet bomb.
Precisely. It processes something like 4 gigabytes of data per second, and the result, a 60% reduction in herbicide use.
60. 60. That is massive money for the farmer.
It's pure profit for the farmer. But think about what this means for Deere. This is a fusion product. The hardware, the sprayer, and the software, the AI are completely fused. You cannot separate them.
Right.
If you take the AI away, it's just a dumb piece of metal. The value isn't the steel anymore. The value is the decision the machine makes in real time.
And this brings up a concept the authors call the MVFP. We all know MVP, minimum viable product. That's a Silicon Valley staple. What is MVFP? Minimum viable fusion product. And the argument is you can no longer launch a dumb product. If you launch a machine today without the telemetry hooks, without the built-in ability to collect data and receive updates,
you're launching a dead product.
It's obsolete the moment it leaves the factory. You have to launch with the capacity to evolve.
Because if you don't, you can't get that data network effect started. You're just building a dead end.
You're locking yourself out of the future. You have to build the nervous system in, even if the brain isn't fully developed yet.
Okay, so that's fusion products.
Yeah.
Making the machine itself brilliant. Now let's move to the right on our matrix. Battleground number 2, fusion services.
This is the race for remarkable results. This is where you shift from selling a machine to optimizing the customer's outcome.
How is this different from just, good customer service? Hey, my tractor broke. Can you come fix it?
That's a great question because it's a subtle but really important shift. Traditional service is reactive. It's about the machine's health. Is the engine running? Fusion services is about the customer's health. Is the customer making money?
Give me an example of that.
Rolls-Royce is the classic case here in aviation. They pioneered what they call power by the hour. Years ago, they stopped just selling jet engines to airlines.
Right.
Instead, they said, we will lease you the engine, and we will charge you for every hour it flies.
So if the engine is just sitting on the tarmac broken, Rolls-Royce doesn't get paid.
Not a dime. It aligns the incentives perfectly. The airline wants the plane flying, and now Rolls-Royce really wants the plane flying. But to do that, Rolls-Royce needs deep, real-time access to the engine's data. They need to predict maintenance before it happens so the plane never stops. But it goes further. Think about agriculture again. A fusion service isn't just, here's your smart tractor. It's, let me help you manage your yield per acre.
So Deere starts telling the farmer, hey, based on the soil data we're seeing from the planter and the weather data we're pulling from the cloud, you should plant your corn 2 inches deeper in this specific part of the field.
Yes.
Exactly.
They're optimizing the farming, not just the tractor. But, and this is a big but, this is where the friction comes in.
Right.
Because to do that, Deere needs to be deep inside the farmer's business. They need data on soil, finances, crop choices, historical yield.
And farmers, I'm guessing, might be a little skeptical about sharing all that. I mean, that's their secret sauce, right?
Rightly so.
Yeah.
This is the challenge of fusion services. You have to earn permission. You have to prove to the customer that if they let you place your data hooks inside their operation, you will give them back 10 times the value and profit. It's a trust game, really.
Data hooks. That's
Yeah.
a key term. It's like you need to hook into their P&L, essentially. You aren't just a vendor anymore.
You're not. You need to move from being a vendor to being a partner. A vendor sells you things. A partner shares your risk and your reward.
All right, so let's move up the vertical axis. Battleground number 3, fusion systems. This is the showdown of smart systems.
This is where we stop looking at a single product and start looking at an ecosystem. We're moving from the Internet of Things to the system of systems.
Okay.
The example the authors love here is Honeywell and the Burj Khalifa, the tallest building in the world.
Which is basically a vertical city. I can't even imagine the complexity of running a building that size.
It is absolutely massive. Now,
Yeah.
a building like that has thousands of systems. You've got elevators, HVAC heating and cooling lighting, security, fire suppression, water pumps.
Right.
And usually these are all separate. The elevator doesn't know what the air conditioner is doing.
They don't talk at parties. They are total strangers.
They don't. But Honeywell comes in as the orchestrator. They create a fusion system, a building twin, that integrates all of these disparate products, even from different vendors.
Why? What's the benefit of the elevator talking to the air conditioner?
Oh, massive benefits in efficiency and experience. For example, imagine it's 8:55 a.m. on a Monday. The security turnstiles in the lobby see 500 people badge in.
The morning rush.
The morning rush. In a dumb building, the elevators would just react when buttons are pushed, and the AC on the 40th floor wouldn't know anything until the rooms start getting hot and stuffy.
Great. It's all reactive.
In a fusion system, the turnstile tells the orchestrator, crowd incoming. The orchestrator tells the elevators, prioritize the lobby, get them ready. And crucially, it tells the HVAC system on the 40th floor, ramp up cooling now, because in 10 minutes, you're going to have 100 warm bodies in that conference room.
That is so cool. It's anticipating the load. It's proactive instead of reactive.
It optimizes the entire environment, not just one component. And this is where the industrial metaverse comes in. Before you even build the next skyscraper, you can simulate these massive systems in a virtual world to see how they interact. You can run all these what-if scenarios.
But there's a power struggle here, isn't there? Who gets to be the orchestrator?
That is the trillion-dollar question. Does the elevator company, Otis, run the building? Does the AC company, Carrier? Or does a third party like Honeywell or Siemens come in and layer over the top of everyone? The authors argue that whoever controls the data graph, whoever can ingest data from all the other players and make sense of it, wins.
It's the battle for the dashboard.
Exactly. If you are just a component supplier, if you're just making the pumps or the light bulbs, you are a commodity. You can be replaced. If you are the orchestrator, you own the value. You are indispensable.
Okay, final quadrant, top right, the ultimate goal. Fusion solutions. The clash of custom solutions.
This, the hardest one, but it's the most lucrative. This is solved by us versus made by us.
Explain that shift. That's a great phrase.
Made by us is firm-centric. It says, I make cars, so I want to sell you a car. Solved by us is customer-centric. It says, you need to get from point A to point B. I will solve that problem for you.
Mobility versus cars.
Precisely. A Fusion product company sells you a Tesla. A Fusion Solutions company sells you a Roto-Taxi network subscription that guarantees you a ride anywhere, anytime, optimized for your schedule. And they might not even own the cars.
Uber is the obvious digital example, but how does an industrial giant do this?
Let's go back to the agriculture example. The problem isn't, I need a tractor. The problem is, I need to sustainably feed the world. Or, more specifically, I need to maximize the financial yield of this farm.
Okay.
A fusion solution might involve a company saying, Mr. Farmer, we will manage your entire planting and harvesting cycle. We will bring the machines, the seeds, the fertilizer, the data. We will take a percentage of the final yield.
Whoa! So they become the farmer, essentially, or a partner.
A massive partner in the farming process. It's completely outcome-based. I get paid a percentage of the money I saved you, or a percentage of the extra crop I helped you grow.
That's risky. That feels incredibly risky for the company offering the solution.
It's incredibly risky if you are guessing.
Yeah.
But if your data graph is good enough, If you know you can deliver that yield because you have data from a million other farms and you know exactly how the weather impacts the soil in this specific region, then it's not gambling.
It's arbitrage.
It's arbitrage. It changes the business model completely. You're not selling steel anymore. You're selling certainty.
You are selling certainty in an uncertain world. That is the ultimate promise of fusion strategy. You are selling the result, not just the tool.
Precisely.
So, okay, we have the 4 battlegrounds: products, services, system, solutions. And the authors make it clear you can't just jump to the end. You usually have to start with products and work your way up.
Right. You have to earn your way up the ladder. You need the Fusion product to get the data, to build the service, to understand the system, to offer the solution. It's a progression. You have to earn the right to play in those higher quadrants.
But how do we actually execute this? Because I can hear our listeners thinking, okay, this sounds great, but my company still uses fax machines. We have silos everywhere.
And that is a very real problem. Strategy is easy, execution is hard. The authors lay out an execution cycle. It's 4 steps: architect, organize, accelerate, and monetize.
Let's run through them. Step 1, architect.
This means you have to redesign the hardware from the ground up. You can't just slap a sensor on a 1980s machine and call it smart.
Yeah.
You have to architect the product to be a data transmission device first and a physical object second.
The data flow has to be part of the blueprint.
It has to be. You need to think about connectivity, processing power, and sensor placement before you pour the first ounce of steel.
Okay. Step 2, organize.
Break the silos. We talked about this. You can't have the engineering team owning the product twin and the sales team owning the performance twin and never have them talk.
Yep.
They have to share the same brain. The sales team and service team are actually the same thing now.
They're the customer success team.
Right. And they're fueled by the same data. If your org chart looks like it did in 1990, you will fail at this. Full stop.
Step 3, accelerate.
This is about clock speed. Industrial companies are used to these 5-year product cycles. You design a car, you build it, you sell it, you wait 5 years for the next model. Digital companies work in 2-week sprints. You have to find a way to match those gears. Tesla updates its car software every month. GM used to update it. Well, never. You have to increase your entire organization's metabolic rate.
And step 4, monetize.
Move beyond cost plus pricing. Don't look at the tractor and say, okay, it costs 50 grand to build, so I'll sell it for 60 grand. Look at the value it creates. This smart tractor will save the farmer $200,000 in herbicide, so I'll sell it for $100,000. Price based on value delivered, uptime, yield, energy savings. Capture a piece of the value you create.
This requires a very different kind of leader, doesn't it? The book talks about leadership principles. This isn't just a tech upgrade. It feels like a total culture upgrade.
It is. And the biggest one is this concept of collaborative intelligence. We have this narrative in society of man versus machine. The robots are coming for our jobs.
Yeah, Terminator style. Or at least automation replacing the worker on the line.
Right. The authors say, stop that. That is a losing mindset. It's not human versus AI. It's human plus AI. The leader's job is to build a culture where humans and machines work together as partners.
How does that look in practice?
The AI crunches the massive data sets to find the pattern the human brain could ever see. The human uses judgment, ethics, and context to decide what to do with that pattern.
They also talk about the 3 horizons.
Yes. Horizon 1 is your core business making the diesel engines. You have to keep that profitable to pay the bills. Horizon 3 is the future, the fusion solutions. The leader has to be ambidextrous.
Right.
You have to manage the present while you're building the future simultaneously. Most CEOs are great at Horizon 1 and absolutely terrible at Horizon 3.
Or they get so obsessed with the future they let the core business crumble underneath them.
Exactly. Balance is the key. And finally, ecosystem thinking. You cannot do this alone. You need partners. John Deere needs weather data companies. Honeywell needs component makers. You might even need to partner with your direct rivals.
Frenemies.
Absolutely. The industrial world is becoming a web, not a hierarchy. If you try to build a fortress, you will be isolated and you will die. You have to be open to sharing data.
Okay, we are in the home stretch here. We have to address the elephant in the room. The book came out right as generative AI, ChatGPT, and all that was just exploding. How does Gen AI fit into this fusion strategy?
The authors argue that Gen AI puts fusion strategy on steroids.
How so? Because I think of ChatGPT as a text generator. It writes emails and poems. How does that help a factory?
That's the consumer view of it, and it's fair. But think about what transformer models, the T in GPT, actually do at their core. They predict the next token in a sequence. based on context.
Okay, the cat sat on the hom and the AI predicts Matt.
Right. Text is just a sequence of data. But you
Mm.
know what else is the sequence of data? The movement of a robot arm, the vibration pattern of a wind turbine, the traffic flow in a city. You can train a transformer model on industrial data.
So instead of predicting the next word in a sentence, it predicts the next failure in an engine.
Exactly. It can ingest millions of maintenance logs, repair manual, sensor readings, and then, this is the magic part, it gives you a natural language interface.
Explain that. Why does that matter so much?
Imagine you're a factory manager. Instead of staring at a complex dashboard of 20 different gauges and squiggly lines that requires a PhD to interpret,
Yeah.
she could just walk up to a terminal and ask the system in plain English, "Hey, why is yield down in Sector 4 today?"
And the Gen AI queries the data graphs.
It queries the data graph. It looks at the process twin, the performance twin. It checks the logs, it reads the manuals, and it answers back in plain English. Yield is down because Robot Arm 3 is out of calibration by 0.2 millimeters, likely due to the temperature spike in the factory this morning at 9:15 a.m.
That changes the game. It completely democratizes the data. You don't need to be a data scientist to understand the
Yep.
factory anymore.
So that's it. It makes the data graph conversational. It bridges the gap between the human and the machine. That is the ultimate fusion. Allows the human to interrogate the machine in human language.
This has been a massive deep dive. I mean, we've gone from $100 trillion GDP to robot botanists to buildings that think. What is the big takeaway here? If I'm listening to this and I work in logistics or manufacturing, or even if I'm just an investor looking at the market, what should I be thinking right now?
I think the summary is this. The digital revolution is over. We won. Digital is everywhere. But the impact of digital is just beginning.
Mm.
We have spent 20 years digitizing information, media, finance, communication. Now we're going to spend the next 20 years digitizing the physical world,
The fusion frontier.
the fusion frontier.
Right.
And the winners won't be the companies that just have the best steel.
Yeah.
It will be the companies that wrap that steel in a digital nervous system.
The authors have a quote I love. The past is prologue and the future is unfolding fast.
It really is. And my challenge to the listener is this. Look at the products you make or the assets you manage. Are you building a brilliant machine or are you just building a machine?
Right.
Are you collecting data to fix things when they break? Or are you collecting data to predict the future?
That's the difference between surviving the next decade and owning it.
Absolutely. The real value isn't in the cloud anymore. It's in the physical world, connected to the cloud.
Well, on that note, I think I need to go look at my toaster and see if it's plotting against me. Or at least if it can tell me the optimal browning setting based on today's humidity.
If it's a fusion toaster, it probably already knows.
Thanks for listening, everyone. We'll see you on the Fusion Frontier.